Lines, page 12, continuing with Voronoi diagrams. In a town, 3 schools, A, B, and C, are located at the points with the coordinates 1, 3, 6, 4, 6, yes, and 6, 1. It is decided that a new school should be built as close as possible to a point which is farthest from all 3 existing schools. All coordinates are in kilometers. Okay, explain why this point will be at the intersection of the perpendicular bisectors of the line segments AB, BC, and AC. Okay, so basically the perpendicular bisectors of the line segments which connect these 3 schools to each other are the borders for the Voronoi diagram. And remember, in the toxic waste problem, the vertices where those perpendicular bisectors intersect are the points that are the farthest from each of the schools. So if you want the point that's farthest from all the schools, then you find vertices of the Voronoi diagram boundaries. Okay? So, and then it says find the equations of the perpendicular bisectors of the line segments A, B, and BC. So let's go ahead and draw the Voronoi diagram. We'll sketch it, and then we'll find the equations of lines that are form the boundaries. So 1, 3, 6, 4, and 6, 1. AB, I'm going to draw the line segments AB, BC, and AC. AB would be AB. BC would be that one. And AC would be that one. Okay, so those are the 3 line segments they're talking about in A, but they're talking about the perpendicular bisectors of those lines. So they would be like, you know, basically like that, and like that, and that would kind of form boundaries that would form the Voronoi diagram, right? Now, in B, they want us to find the exact perpendicular bisector equations for AB perpendicular bisector and BC perpendicular bisector. So let's go ahead and do that, okay? And let's get rid of all these, okay? And I'm going to draw a better AB, and I'm going to draw a better BC, okay? And then I'm going to draw a let's see, I'm going to do a highlighter to draw the boundaries. So like one of the boundaries kind of like that, the other boundary is kind of like that, okay? And I'm going to find the equations for these. Remember, to find the equations of these yellow lines, first thing you're going to do is you're going to find the midpoint between the 2 schools. Okay, so between the red and the blue schools, remember red is 1, 3 and B is 6, 4, we can find the midpoints by looking at X bar, Y bar, and 2 bar stats. So I'm going to put 1, 3, and 6, 4 in stat edit. One, 3, and 6, 4. And then I'm going to do stat, calc, 2 var stats. And L1, L2 blank is what you want. And X bar is 3.5 and Y bar is 3.5. So the this point here is 3.5, 3.5. So I marked it pretty well on the graph because that's what it looks like on the graph too. And then I need to know the slope that this line should be. And the slope of the yellow line depends on the slope of this line segment, which connects red and blue. How do we find the slope of that line? Well, if we find the slope between red and blue, that would be the slope of the black line. Then we would just find the perpendicular to that black line. So let's do that. We already have red and blue in stat edit, so now we just do stat calc lin reg. And L1, L2 blank is what we want. Then we go down to calculate. And the a value in the Lin-Reg equation is going to be the slope. So the slope of the black line is 0.2. Let me write it in black. Okay, and then the slope of the yellow line should be -1 over 0.2. So the slope of this yellow line is going to be -1 over 0.2. And if I want to see what that is, I can use the calculator. -1 divided by 0.2 equals -5. Okay, so the slope of this boundary is -5, and it goes through the point 3.5, 3.5. And so we start with the point slope form. So I'm going to put this equation right here. I'm going to write it here. Y minus y1 equals m times x minus x1. What's our x1, y1? x1, y1 is 3.5, 3.5. What's our m value? -5. So this first boundary, or this first yellow boundary, is going to be y minus 3.5 equals -5 times x minus 3.5. Whoops, went to the wrong page. Okay. All right, there we go. So that is this line here. Now let's do the other one. So what is the midpoint between blue and green? We can find the midpoint again by doing stat edit and putting blue and green in here. Blue is 6.1 and green, blue is 6.4 and green is 6.1. We just need to replace the first one with 6.1 because the other one is already 6.4, and it doesn't matter what order you put them in. Okay, so 6.1 is the green one, 6.4 is the blue one. I got them both into stat edit now. I'm going to do stat calc 2var stats to get the midpoint value. L1, L2 blank is what you want. And the x bar, y bar values are 6, 2.5. So I can label this point here 6, 2.5. Okay, and if I drew it pretty well because it really looks like it's at 6, 2.5. Now I'm going to substitute 6 and 2.5 into my point slope form. But before I do that, I need to know what the slope is for this line. And when I look at this line, this yellow line, it's actually flat, isn't it? Because the vertical line is totally vertical. The line between blue and green is vertical, totally vertical. So the slope here is infinity. And so that means that the perpendicular would be the horizontal line, which would have a slope of 0. And if you substitute in, I'm going to put y minus 2.5 because my y value of the midpoint is 2.5 equals, and then I'm going to put 0 for the slope, and then I'm going to put x minus 6 because 6 is the x coordinate of the midpoint. And you can see if I multiply 0 times x minus 6, it's just 0. So then I get y minus 2.5 equals 0, and then I find out that actually the equation of the second yellow line would be y equals 2.5, which should look familiar. It is the equation of a horizontal line. So that is my second Voronoi border equation. Okay, so that was the one that is between, it might help if I label these A, B, and C. Okay, A, B, and C. Okay, C. Hence, find the coordinates of the point where the new school should be built. Okay, so based on these two lines, y equals 2.5 and y minus 3.5 equals 0.5 times x minus 3.5, it says to find the point where the school should be built. Remember, the vertex, the intersection between those 2 points, is where the school should be built. Okay, and in order to find intersections, how do I do that? I do second calc intersect on the calculator, right? And in this case, I am going to put this line and this line in the calculators, but only one of them is ready to put in the calculator. Y equals 2.5, we can put that directly in the calculator, right? Because it has y by itself on the left side. But the other one we don't. It says y minus 3.5 equals negative 5 times x minus 3.5. We need to put this in a form where y is by itself on the left side, so we need to get rid of the minus 3.5. The opposite of minus 3.5 is plus 3.5, so we add 3.5 to both sides, and we end up with y equals negative 5, parentheses, x minus 3.5, and then plus 3.5. Wow, I had to write that really small, so it doesn't look very good. Let me see if I can, let me see if I can redo that by zooming in. So y equals negative 5 times x minus 3.5, and then I would have another 3.5, except this time I'm adding it. Okay, so I'm not going to do distributive property and simplify this because I don't want to make a mistake, and it's not necessary because the calculator is fine with it not being simplified as long as y is by itself on the left side. Okay, I forgot the point. Negative 5 times x minus 3.5 in parentheses plus 3.5. Okay, and now I'm going to graph these. And what I'm seeing here are the two yellow lines, except instead of line segments, I'm seeing them go, forever. Okay. And it looks a little bit different because of the scale, but that's okay. So basically I want the intersection of those 2 points. I find those by doing second calc intersect, which is option 5. And then I hit enter 3 times. And the intersection is 3.7, 2.5. So the answer to this point right here is 3.7, 2.5. That is the point where we should put the new school. And is that all they asked? Determine how far. Oh, now that was to find out where the new school should be built. Now, determine how far the new school will be from each of the other schools. Okay, now to do this, we're going to have to do the distance formula. Okay, remember the distance formula? So the way the distance formula works is, if you look back a few pages, I think on page 1 we did distance formula. So we're going to take the distance formula, which is the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Okay, and that is the distance between the 2 points. All right, so we're going to do that between, and I don't want to confuse you by having 2 blue points, so let me go ahead and make the new school a black point. Okay, so we're going to do red with black, blue with black, and green with black, and those will be the 3 distances. Okay, so basically what I'm going to do is I'm going to have, and this is where it's really handy to know how to do copy and paste on your calculator. So for the first one, I'm going to do red and black. Okay, so my red point is 1, 3, right? So I'm going to do 1, and then I'm going to do minus 3.7, which is my black x coordinate. Oops. And then I'm going to put squared. And then I'm going to add it to, and then the y coordinate of red is 3. And then I'm going to subtract the y coordinate of blue, or black, which is 2.5, squared. And then I'm going to hit enter. And that'll give me 2.75. So the red to black distance is 2.75. Okay, and then now I'm going to do blue to black distance, this distance here. The way I do that is, now the second pair, which is 3.7 and 2.5, that doesn't change because that's the black point, right? I just want to change the 1, 3, which was the red point. I'm going to change that now to 6, 4. So I'm going to go, do you see I copied and pasted that one? And now I'm just going to change the 1 to a 6. This doesn't take as long with a real calculator. 6. And then the 3, I'm going to change to a 4. Isn't that easy? And then you hit enter, and oh, it's also 2.75. What a coincidence. And then finally, I'm going to do the green to black distance. The green to black distance, instead of 6, 4, I'm going to put 6, 1. So the 6 actually doesn't change because the x-coordinate for green and blue are the same. And then I'm just going to change the 4 to a 1. And so the green distance is, what do you know, it's also 2.75. So that kind of makes sense, right? The optimal place to put the new school is the same distance away from all the other schools. It's like not too far, not too close to any of the other schools. Okay, and that's exactly what the Voronoi diagram does. It tries to find those positions that are as far away as possible from all the schools at the same time. Okay, so let's try to do the next problem then. So 2. At a fair, there are 3 hamburger stands, A, B, and C. The fairground is in the shape of a rectangle with dimensions 100 meters by 50 meters. 100 meters by 50 meters. So I'm going to just draw the edges. So this would be 100 and this would be 50. If I assume, and I'm just going to change this, this will be 20, 40, 60, 80, and 100 in this direction. And this will be 20, 40, 50 in this direction. So basically we're working with this field here. Okay? And there's 3 hamburger stands, which are A, B, and C. And the fairground is in the shape of a rectangle. The bottom left corner of the field can be regarded as the origin of the coordinate system. That makes sense. So this is the origin, 0, 0, just as we did it. And the diagonally opposite quarter as 100, 50. Yep, there it is. The hamburger stands are at the points 20, 30. I'm going to do that one in red because it is A. And then hamburger stand B is blue, and it will be at 80, 30. And the next one, C, is 40, 10. That is green. Okay, so those are the 3 hamburger stands. I'm just going to get rid of these fat yellow lines because they get in the way a little bit. And then it says to find the equations of the perpendicular bisectors of AC and BC. So first thing I'm going to do is I'm going to draw the line segments which actually connect. Oh, and I'm going to label the points, okay? A, B, C. So it says to perpendicular bisectors of AC and BC. So AC, it would be this line, and BC would be this line. We want the perpendicular bisectors of these lines, which would be like this and this, right? We want the equations of those perpendicular bisectors. Okay, so first of all, we need to find the midpoints. And the midpoints, let me get a highlighter that's not so thin. So the midpoint would be here and here, okay? And then we would just find the slopes of these lines which connect the hamburger stands, and then we would find -1 over those slopes to find the perpendiculars, and then we would use point slope form to find the equations of the perpendicular bisectors, right? So let me just erase this now, and we'll go step by step. First thing we're going to do is we're going to find the midpoint between AC. Oh, it's a terrible picture. Okay, midpoint between AC looks like it's going to be 30 comma 20, right? So let's make sure by doing it in the calculator. So we're going to put the coordinates for A and C in the calculator in stat edit. So remember, A is 20, 30, and C is 40, 10. So I'm going to put 20, 30, 20, come on, 2, 0. It's really hard to press on this thing. 20, 30, and then the other one is 40, 10. And we can find the x bar, y bar, which would be the midpoint of these two, by doing stat calc 2var stats. L1, L2, blank. And the answer is 30, 20 is x bar, y bar. So this midpoint is indeed 30, 20. And then what we want to do is, we want to know what the slope is of the black line which connects AC. We can find that by looking at the slope value given in stat calc ln reg. L1, L2 blank. And the A value is going to give us the slope. It is -1. So the line which connects red and green, the solid line, has a slope of -1. The slope of the dotted line, which is going to be the boundary, is going to be -1 over -1. And -1 divided by -1 is just +1. So the slope of the perpendicular bisector is going to be +1. And so how do we find the equation of that line? We're going to start with slope, point slope form, also known as point gradient form. It's very hard for me to remember that. Okay, so and then we're going to put 30 and 20 in for x bar and y bar. Make sure you put them in the right order because a little bit tricky. 30 is on the left here, 30 is on the right here. Slope is going to be +1. So now we're going to write it out. Y minus 20. Don't fill in the x's and the y's, otherwise it's not going to be an equation for a line anymore. And there you go. That's the equation of the first perpendicular bisector, which answers this question here. Now we're going to do the same thing for B and C. So for BC, I can see that probably the midpoint's about here. But to figure out exactly, let's do stat, edit, and then 2var stats. So the coordinates for green are 40, 10. We already have that in the calculator. The coordinates for B are 80, 30. Let's put that in. 80, 30, 8, 0. Come on, calculator. Okay, and then we do stat, calc, 2var stats, and that'll give us x bar, y bar. L1, L2 blank. And x bar is 60 and y bar is 20. So 60, 20 is the midpoint. The dotted line, which is the perpendicular bisector of that solid line, is going to have a slope which is -1 over the BC slope. How do we find the BC slope? Easiest way is stat calc ln reg and look at A. So we go to 4. And we look at L1, L2 blank is what we want. And the slope is 0.5. So the slope of this one, the perpendicular, is equal to -1 over 0.5, which if you compute that in your calculator, it's going to be -2. Okay, so that means that if we wanted to find the equation of the perpendicular bisector BC, it would be y minus, we would take the y coordinate 20 equals -2, which is from there, x minus 60. So that is the equation for the perpendicular bisector of BC. you notice that we can just leave it in the point slope form, the point gradient form, because it doesn't say what form they want it in. People will always go to the hamburger stand that is closest to them. Draw the Voronoi diagram that represents this situation. Okay, so now what I'm going to do is I'm going to use the highlighter to extend these borders. So there we go, there we go, there we go. So basically, if you're in one of these regions, that's when you're going to decide which hamburger stand you're going to go to. There's only one border that we didn't really draw, which is this border here. What is the border between A and B? It would be exactly in between AB and vertical, because AB are at the same vertical point. It would be like that, right? So it would only affect these people here, right? Because the edge of the map is there. So it only needs to go down to 50, 40, and then it stops, because after that it's the region for C. Okay? So basically the I'm just going to highlight a little bit using green, for example. I'm just going to highlight the green region using green. I'm going to highlight the red region using red. I'm going to try to change the opacity. Okay, like red is like that. And the blue region will be like that. Okay, so if you're in the blue region, you're going to be served by the blue hot dog, hamburger stand. That's the one you're going to go to because it's closest. And the red one and the green one also. Okay, so we've already done that. We've drawn the Voronoi diagram. C, find the area of the region of the fairground which is closest to stand C. So stand C is the green region. Okay, find the area. Oh, we're supposed to find the area of the region. So like stand C, look at that. It is a triangular area. And so basically we could find the area of this triangle using counting squares, or we could do 1/2 base times height, right? So what is the base of this triangle? It is, goes from 10 to 70. So the base is 60 long, and the height appears to be 40 tall. So basically that would be 60 times 40 times 1/2, which would be equal to, I think, 2,400 divided by 2, which is 1,200. So the area served by stand C is 1,200. What about stand A? Stand A, I think I'm going to divide this into two pieces. One of the pieces is going to be this triangle here. Okay, this triangle here. And then the other two pieces are, I'll just count the squares. Okay, so this triangle here has a base of 1, 2, 3, 40. It has a height of 1, 2, 3, 40. And if I multiply 40 times 1/2, it will be 1,600 divided by 2, which is 800. So the area of this triangle here is 800. Okay, and then I just need to add it to 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Each one of these squares is 10 by 10, which is worth 100 also, right? So I have 9 squares worth 10 each, so that's 900. So I can add 800 to 900. So the area for stand A is actually 1,700. Okay? Let me go through that again. Okay? So the red triangle here, okay, the red triangle here has a base of 1, 2, 3, 4. It has a height of 1, 2, 3, 4. Okay? Actually, they're 40 long. It has a base of 40 and has a height of 40. multiply base times height times 1/2, 40 times 40 times 1/2, and you get 800. Okay? Then the rest of the squares, which are here and here, you can just count the number of squares. Each square is 10 by 10, so it's worth 100 in area. So 9 times 100 is 900, and then you add the 800 to the 900, and you get 1700 for the area of stand A. For people who are doing Voronoi diagrams right after we do lines but haven't done a lot of area yet, don't worry about the area problems yet. For those of you who are doing this after you've done trig and solids, you do need to know how to do that, right? That should be simple for you. Okay, part D. A fourth hamburger stand is to be added to the fairground at a point as far as possible from the other 3 stands. State the coordinates of the position at which it will be built. Determine how far the new stand will be from the other hamburger stands. Okay, so actually, if I didn't draw the drawing so well in the first place, I wouldn't know that actually this point, this critical point, which would be the point that is equally distant from all 3 hamburger stands, which would be that point where the 3 borders intersect, 50, 40, maybe I wouldn't know that. So what I'm going to do is I'm going to take these 2 equations, which are the equations for the 2 diagonal borders, and I'm going to put it in the calculator and find the intersection so that I can find the exact coordinate 50, 40. Okay, now these are not quite calculator ready. In order to make them calculator ready, all I need to do is add 20 to this one, add 20 to both sides for that one, and add 20 to both sides for this one. I'm not even going to do distribution because I don't want to mess it up. Now I'm going to put both of these calculator ready functions into y equals, and then I'm going to do second calc intersect. So I don't need to put the 1 there because multiplying by 1 does nothing, right? X minus 30 parentheses plus 20. This one actually was pretty easy to simplify. It would be x minus 10, right? The other one would be negative 2 times x minus 60 parentheses plus 20. Okay, and I'm going to graph them, and I'm going to find the intersection. And of course, look at the scale of this picture. It's actually in hundreds, right? And my scale in the default here is like tenths. So I need to change my window so that it's just as big as the original picture. So I'm going to change my x max to 100, and my y max I will change to 50. You can change it to 100 too, but and then for sure I will see the place where they intersect. So that's my line between red and green regions, and the other red line is the line between the green and the blue regions. So I want the intersection point of those two. Second calc intersect, enter, enter, enter. And the intersection is 50, 40, just like we thought it was, okay? So that is the answer for D1. State the coordinates of the position at which it should be built, 50, 40. And the last question is, determine how far the new stand will be from the other hamburger stands. So remember, when we do this, we're going to use the distance formula, this distance formula right here, which, and we're just going to type in the appropriate coordinates. So first thing we're going to put is we're going to do distance from red to black. Okay, and red is 20, 30, right? 20, and then we'll put, now we're going to put the x-coordinate of black, which is 50. Remember, x1 minus x2 squared, so that's x1 minus x2 squared. Then we're going to add that to, and then we're going to put the y-coordinate of red and the y-coordinate of black. The y-coordinate of red is 30, and the y-coordinate of black is 40. So 30 minus 40 squared. And then we'll hit enter. And the distance from red to black, let's use this now. So red to black, the distance is going to be 31.6. Okay? What about the distance from blue to black? The distance from blue to black, that will be, the blue coordinates are going to be 80, 30. So we'll change the first number in this expression here to 80, because instead of 20, 30, it's going to be 80, 30. So we change the 20 to the 80, and the 30 is the same. So all we need to do is change that to an 8. And, oh, the distance is also 31.6. And then what about from the green dot to the black dot? So the green dot is 40, 10. So let's change the 80 to a 40, and then the 30 to a 10. Remember, the 30 changes to a 10 because the green dot is at 50, 10. The 40, 10, and the 80 changes to a 40 because it's 40, 10. Okay? 40, 10. Okay. And once again, it's 31.6. So, what do you know? The green distance is also 31.6. They are all the same distance away from the new hamburger stand, and that's why it's the optimum position. They're trying to make it as far away as possible from all the hamburger stands individually, and that's the result. So that's it.